Okay, good afternoon. We will start our lectures today. Remind you about the lab test too. It's 15%, and next Monday. And we have two sections, 1 and 2. Okay. Please make sure you don't miss the lab test 2 because there is no makeup for the lab test 2. What we discussed in the previous lectures, we discussed generic and interface. In specific, we touched the topic of sorted interfaces, which actually we used on the lab 4. If you already looked at the lab 4, you will see that we have used comparators and comparable interfaces. Both interfaces are available for us to be used and allow us to sort the object that we create in our application in such a way that ordering the object, which one is the first, which one is the maximum, which one is the minimum, based on the criteria that we provide on the implementation of the interface of comparators or comparable interface. And also we discuss using the collections. We mentioned last time that we have list as an interface, set as an interface, and map as an interface. And we cannot create an object from interface. So we cannot create a new list. But we can create an array list, because array list is a class. Implement this interface. Implement list interface. So we're going to come also today to talk more about using the collections. The material of using the collection is already posted from last lectures, so you have it on the Moodle in advance. And hopefully we can today start introducing the topic of inheritance. Now, if you look at the course outline, we supposed to cover the big O, the time complexity, immediately after we use the collections. But we shifted. So we're going to cover big O before recursion. It will be more useful for you to calculate the time complexity of a Java method or Java algorithms when you are trying to implement a recursion method. So we just shift the topics. We're going to introduce inheritance because lab number 5 will be based on the inheritance. So once we release lab number 5, you will be able to solve that lab. Okay, using the collections. Last time we covered the list collections and set collection. Today we're going to go back again to the set collection because it's very important. Here today in this slide, I want to remind you that we have an interface called collection. So interface, that means we have some set of methods, okay, inside this interface. Then we have another interface that extend the collection interface. It's called list interface. And we have an abstract class called abstract collections, which is also implement this interface. Again, abstract class has some similarity to the interface that we cannot create object from abstract class. So if you have an abstract class, you cannot create object from abstract class. You have to extend this abstract class to create an object, similar to the interface. We cannot create object from interface. And we have another interface called set. Both are extending the collection interface. And then we have abstract list. And below we have array list, which is most commonly used by students. And many of examples in this course, we use array list. We have linked list. And also we have hash set and tree set. Today we're going to go over the set a little bit quickly and discuss what is the characteristic of set interface that is different from the list interface. And when is actually the students are decide to switch from using list, then he decide to use set. Why? What's the difference between list and set? The difference here is that set does not allow a duplicate element inside the set. We cannot insert two elements. If you have element 1 and element 2, and element 1 dot equals element 2 retain a true, there will be only one element inside the set. We cannot insert element 2. And any attempt to insert element 2, which is equal to element 1 inside the set, will be ignored. And that is the risky thing. You will not receive any notification from the compiler that this insertion E1 is already exists. It will just ignore your insertion. You will not notice that actually the element is exist or not. Okay? So if you have a duplicate element, set will not allow you to insert it, while the list allow you to insert duplicate elements. And they will be in the same order as you insert them. In the other issue about the difference between the set and the list is there's no order. The set does not keep any orders of the element while you are inserting them. They are inserting in different different orders, because the set need to guarantee that the elements are unique inside it. Okay? Now, there is two main methods that are implemented by the interface called set, which is add and remove. And you can see from the header or the signature of this method, add object. The type of X is an object. Okay? It's more generic, not a generic type. It's object, which is the superclass or the main class on Java. Remove object X. These are the two main methods that are used with set interface. Now, again, this is another note that we are not maintaining any order inside the list, inside the set, different from the set. So, items are not guaranteed to be added, because add will ignore any duplicate elements. Just again, repeat what we have said. Now, we have the set as an interface, but we cannot create object from the set because it's interface. Now, Java provided for us what we call a HashSet class. HashSet class extend the abstract set and implement the set interface. When the class implement the interface, it will provide all the implementation for the method inside that interface. So we have add and remove as a method for the hash set. HashSet maintain what we call a hash table. And the definition or the syntax or the generic class, if you want to use a generic type, you use a class HashSet, and between the triangle brackets you have E. E indicate for a generic type can be any object or any element. Now, you will not actually see the hash code. The hash code will be automatically generated for any object inserted inside the hash set, and the hash set is used the mechanism of the hash code to index the element. And as I mentioned, the hash code is perform automatics. And we rely on your implementation. If you are using, for example, a vehicle, you create an object of type vehicles, and you want to insert it inside the hash set, the hash set will look first to your implementation for the hash code method. If you didn't provide a hash code implementation, it will look for the object implementations. Okay? So if you want to insert an object inside the hash set, or using HashSet or HashMap or whatever you, as long as there is a hash inside in the front, you have to provide the implementation for the hash method inside your objects. Again, you cannot directly access the index of the hash table. You just ask for the object, and the hash set will transfer this object to the hash code and find it out inside the set. And this kind of mechanism of hashing will allow us to execute add, contains, remove, and size with very constant time. Okay? Okay, again, this is about the object. If you want to add the object to the hash set, it's good to implement the hash code method inside your objects. Now, how you can construct the hash set? There is 4 ways to construct the hash set. First, the no argument constructor. You just simply say new hash set, and you give the curly brackets. So a new object of hash set will be created for you. Or you can decide to create a hash set from different kind of collections. You have some previous collection is already created. Here is collection. You see, the name here is collection is the name of the interface. The name of interface. So it can be array list, set, any other things, because collection is an interface, can be used as a reference type. So here any collection, any previous collection you already created, and we have a question mark here as a wildcard, anything extend from E. So it can be E or anything extend from E, and you initialize or you construct a hash set from some previous or some existing hash collection, sorry. Or you can ask the compiler to create a hash set with some integer capacity. You give a capacity, I need the hash set for 100 elements, 200 elements. Or you can ask hash set with some integer capacity with some fill ratio. Now, the default for the capacity is 16, and the default for the fill ratio is 75. What do you mean by that? Before you extend, for the compiler extend your hash set, the hash set should be at least full 70%, 75%. Okay? Because the compiler will extend, okay, the hash set automatically for you because it's automatically growing or shrinking. Okay? So if the hash set is full more than 75%, the compiler will extend it for you. And you can specify this ratio in the constructor. Now, this is very important note. So HashSet does not define any additional methods beyond that is provided from the superclass or the interface. That means add and remove methods contains all these methods. There's no extra method. Just simply all the method inside the set interface will be implemented on the hash set. Now, this is an example about how to use the hash set. Simply I asked to create a hash set of string. Okay, I use the generic constructors. I construct the hash set and empty hash set. Okay, I start add element P, A, D, E, C, and F. You see the order of insertion. Then I ask to print it out. Do you think now they will be printed on the same order I inserted? No, there is no guarantee. There is no guarantee. If the questions or multiple choice questions given to you like this, there is no guarantee of order. No one can predict the order. It's different from different machine because it will rely on the string hash code when it's inserted. So if I ask to print, check the order. You see that E and F and C are switched. Maybe P, A, and D stay the same, but C, E, and F are totally not the same as the order we insert them. Okay? Now, this is another example about how to use the hash code. The objective from these two examples is to let you know how you can look inside the hash set and bring out the value from the hash set and print it out if you want. Okay? So you can check and look at the element. Look here, we define a hash set and look at the declaration type as a set. Set, not a hash set. The previous question we use hash set. Okay? But now I use set more generic, which is more recommended to use set as an interface as a declaration type. So I use set of strings, then I declare a new hash set. I start adding the name of the cities, okay, as a strings. Then I decide to print it out. Okay? They will print it in some kind of random order based on the string and hash code generation. Look at the second for loop. It's a for loop. Okay, how I can look inside the element. I cannot find the index. I cannot say, give me the element of index 2 or element index 3 because I don't know what is that. Okay, so I have for loop as string, comma, and we have set. So we look for all the element and we print it on a bus just to distinguish this from the previous one. And look at the last one, how we can use for each. For each element, E, and we put the arrow, you need to do the E dot two lowers and we print it out. This is another way you can ask for each element inside the set. Okay, you see here set dot for each and E, and set is actually the name of this set. This is the output. Okay. Now there is another type of set is called linked hash set. Is the only difference between the linked hash set and the hash set is you trying to sort things on the hash set, but you need to keep the order. Okay? You need to keep the order and maintain the order. That's the only difference. This allows you to insert the order and iterate over the set. So that is something you need to merge between two functionality. I need the hash set to be quick, but I need also to maintain the order of the element that I insert inside the hash set. Okay. Again, the same constructors, linked list, linked hash set, empty constructor. You can start from some other collections that you have, or you can start with some capacity or fill ratio. Is the same thing. This is an example of creating a linked hash set. You add the element P, A, D, E, F, and C, and now, do you think when we print it out, we print it on the same order we insert, or we have some kind of random order? Same order, because that is what we need and the objective of using linked list, linked hash set. Actually, there is no method. There is no method get index or something like the list. Okay? You have to look at the interface. If the interface of set provides such kind of methods, okay, then you can find the third element or fourth element. Okay? But if the interface does not give you any method that can retrieve an element at a particular index or change an element at a particular index, you cannot do this. You need it to be fast, okay, to search if it's contained. But again, when you need to print it, you need to print it in the same order. Okay? There's some application, you need that functionality. Okay? It depends on the application. Today, we just cover all the possibility, and you pick whatever you like. Whenever you design applications, you say, I need a hash set. I don't care about the order. No, I need the hash set functionality, but I need to maintain the insertion order. That is the beauty. So the element will be inserted on the order. But again, I need it to be fast in case if I need to check if the element inside or not. Okay? Now, this is a very good example, and this is map is actually considered one of the powerful collections inside the Java. Understanding the map will actually, if you understand it, that is my best practice to you or advice. If you understand the map, how the map is working, you will start using the map everywhere. Okay? Because it's merged between two functionality that is actually unique here. And like another languages, is start taking this map and implement it. Like if you have experience on Python, you see some kind of dictionary in the Python. The other type is called dictionary. Is actually map. Okay? So the map is separate from the list and the set. It has a map interface. And then we have abstract map, and we have what we call a hash map. To maintain the order inside the hash map, we have what we call a tree map, which is implement another interface called sorted map. Okay? What is the map as an abstract data type? Is actually the link. Is actually the link between the, you have a key and you have the value. You link between the key and the value, which is the same as the dictionary. You want to see the definition of any particular word inside the dictionary, you start looking for, oh, what's the word, what's the first letter inside it, the word, and you start flipping the page until you identify the word, and once you identify the word, and you retrieve the value, which is the definition for your word. The same thing in your phone. You want to find your friend phone number. You start finding his name first, then after you find his name, you try to retrieve the value of the name, which is the actual numbers. So this kind of mapping is actually exists in our life. Okay? Exists in our life in many applications. So the idea is key value pairing, and what we call it is a dictionary, this kind of mapping. Okay? So you can have the key only once, but you can have only one value associated to that key. So in some definition or the formal definition, the map is an abstract data type that stores a collection of a unique keys. So the keys is unique. What is the best data type that provide the uniqueness here is a set. Set will not allow you to insert duplicate items. So it's a collection of a unique set, unique keys, and their associated value. Each key is associated with a single value. You cannot have like the same key associated with different value. Now, in the map, the keys are the elements, and they are used as an index. If you look at the array, if you define any array of integers, you start using 0, 1, 2, 3 to retrieve the element at index 0 or 1 or t. Now, if you are using the map, the key is actually your index. You start addressing the key as an index to retrieve the value inside your map. The beauty here is if you are going to the array list, you're going to use 0, 1, 2, 3 as an integers for the index. But here the key is an opportunity for you to use the key as an object. So we can have the key as an object inside the map. Here is an example of a map. We have the key and the value. All the key and the value contain as a one entry value. So this is the number and the name. So then both key and the value as one entry inside the map. What is the basic method that the map interface provided for us? We can put object key with object value. So here is the key, is the object, and the value is another object. We can insert it inside key. Now, this is an example. You have a map, .bot. You give the key, and you give the value. The action is actually inserting this entry, one entry, inside your map. To insert one entry inside the map, you have to provide the key and the value. Get object key. You retrieve the object by using the key value. Now your key is actually object. You use it as an index and will retain null if this key is not exist inside the map. So for example, you decide to get pop. You want to see the value. It will retrieve the value, v. It will retain the value v for you from the map. Now, if the key that you provided is not exist, you will have null as a retain type. Remove. You remove the element from or the entry from the map by providing the key. You give the key value as an object to the map and it will be removed. Remove pop will remove it from the map. It will remove both because both are one entry. The key and the value as one entry. You remove all this entry. Yes. Retain the size. It will retain the size of the key list. Size of this map will be 4. You can clear. Clear, remove all the element from the list. Is empty, you can ask if this map is empty. All these methods are coming from the interface called map. Remember, whenever we say interface, I cannot create object from interface. So we should have some other method that implement this map interface so we can use it. Contains key. You give the key value and you ask if your map contains that key or not. It will retain true or false. So I have the map. I ask it contains key. I provide the key pop and it will retain it true because it exists inside the map. There's no change after checking if the key is in the map or not. So after this method, the map will not change. I can ask for a max is not there, so I will retain false. Contains value. I can ask for a value if the specific value is inside the map or not. So I will ask for the value. If the value inside the map, I will retain true. Otherwise, I will retain false. Key set. I can retain a set of keys. So if someone needs all the keys inside the map, he can use .key set will retain a set. So look here, set is an interface. It will retain an object that can be assigned to the set interface. I can retain a collection, and again, collection here is an interface. I can retain a collection that can be assigned to a collection interface for the values. So there is a difference between the set and the values. I can have duplicate values inside the map, but I cannot have duplicate keys. That does make sense. When I retain a list of key set, it will retain a set because set will not allow any duplications. But the list or collection interface allow duplications. Okay? But the association between the key and the value should be one-to-one. Okay? Keys should be unique, and the association, the link between the key and the value is on one-to-one. We cannot have the same key assigned to different values. Now, after discussing all these methods, that is back to the map interface, we will see now two classes implement this interface. One is called HashMap, and the other one is called tree maps. You have a question? It will remove the value automatically because value and the key has one entry. Okay? You try it. See. But actually when you assign the map, you specify the type or the object of the key. Okay? I don't think a null object will be allowed as a key. Okay? You specify. You cannot have arbitrary keys like you have a map where the first key is at integers, the second key is in string. No. You have to specify the type of the object of the keys. The values is okay. The values is okay. The link between the key and the value is one-to-one. You can have a repetition of the values. You can have the same value, but they are assigned to different keys. Okay? So HashMap and tree map both are implement the map interface. The HashMap is an efficient to allocate the value, insert inside the map, and delete from the map. The tree map is actually about sorting, maintain the sorting inside the map. So that's why we have two classes, HashMap and tree map. So if you look at the HashMap and you want to use the HashMap, you have to implement Java utility, and the idea is behind it is again is association between the key and the value. So the key is an object that never appear more than once inside the map. Okay? And we can use this key to identify the value. So the map, HashMap, can execute get and bot in very fast way in constant time. The constructor for the HashMap is class HashMap key for the type of the keys and V for the type of the values. And again we have for constructor either to decide to construct HashMap empty constructors, or you start constructing a HashMap from different maps. You see here is not a collection, is a map, different map that you already created in the previous step in your application. You want to start a new HashMap, you can give this map to the constructor and start from that point. You can start a HashMap with integer capacity, or you can start a HashMap with integer capacity again with fill ratio. The same default value from the same as the previous slides. Now, these are the very essential methods that we use with the HashMap is map.bot, you give the key and the value, map.get and the key and the value. In addition to these two methods, you have the method that exist on the map interface. This is an example to create a hash map of the grades of the students. You have the first, you have a generic types as a string and string. So you give a string for the name of the students and string for the grade. You start insert the element inside the map. The first entry, all of this, the key and the value, that is the most thing here, is to keep in your mind the key and the value represent as one entry. You cannot remove the key and leave the value. You have to remove both of them. It will automatically actually remove for you. So you insert inside the map the element. So whenever you insert element, you put inside the map, you will put one entry, key and the value. that's just for example. Now, this is another example about HashMap. We will define a HashMap of the key for the strings and the value for the double. This is the string as a key and double as a value. Inside this HashMap, we insert students 10, 12, 54, and 33, and 87 with some kind of arbitrary double values. Now, after we insert the hash inside the HashMap, we retrieve the element, the set entry.set. We retrieve the entry from the HashMap, and we can see here the type is map.entry string and double. And then we go through all this map.entry to print them out. Okay, so all the entry inside the map. This example is good to go through it and try to run it in your computers to see how you can navigate the HashMap elements. Now, if someone decided to change the value for the entry student 33, so he will ask to get the value, ask hashmap1.get, and you give the key. The key here is the name of the student, student 33. We retrieve the value, then is asked to put and give the key and also the new value. And then we'll ask to get the value again to print it out so you can see that the value is changing. You can here see the value of the students before and the value after we add 99.1 to the value. This is an example will demonstrate how we can print the hash map and how we can get the value, how we can change the value and put it back again to the hash map. This is another example to see the difference between HashMap and tree maps. So you define the hash map, you add some values, cities with some arbitrary integer values, okay? Then you print the hash map. After that, you start creating a tree map from the previous hash map. You see the constructor in this step? We use the hash map that we already created on the first step. So we start creating a tree map from the hash map. What's the difference between the hash map and tree map is the tree map implement the sorted interface. So the element will be inserted inside the tree map and will be stored in the same order we insert them. Okay? And we try to print the tree map again and look about the last iteration, how we can use for each method to go over all the elements inside the tree map and print them out. So this is how we print the element out. So you see the order in the hash map. San Francisco was the first, but it actually is the last one when we ask for the ascending order for the cities. Okay? After we cover the set and the map, we will have here what we call a collections. It's different. That is collection interface. This is a collections toolbox. Collections toolbox is actually utility class. It's different. Don't get confused between collection interface and collections. Collections is part of Java utility also. It has all static method. That means we can access this method by providing collections dot binary search, for example, and we can give a list and give a key and ask, okay, to find the key inside the sorted list. So the binary search, one of the preconditions for the binary search is the list should be sorted in advance. So we provide the list and we provide the key and try to find the element inside the list. You can ask collections.sort. You give the list, it will sort it for you. But will be based on what? We sort the collection based on equals, compared to, or comparator. If you want, you can put comma and put comparator. That's right. So when we ask collections.sort, a list of an object, for example, a vehicles in the lab number 4, we create a vehicle as a class, as an object, and we provide an implementation for a comparable interface. That means we have a compare to method inside it. Then when we ask collection.sort, for a array list or a list or a set or whatever is a hash map, we look inside the compare to and we sort the vehicle based on the criteria we provided inside the compare to. If you want to sort the collection or a list in some specific criteria, then you have to go and implement a comparator interface. You create a new class that implement a comparator interface. You provide the implementation for a comparator method, and then you start here putting sort list, comma, a new object from that list. Minimum and the maximum. How we can determine minimum and the maximum of the list? Again, by looking at the compare to method. Reverse. You can reverse the list. All these are static methods that can work with any type of list. Okay? You can swap, you can replace, you can shuffle the element inside the list. So these are static methods, again, to make sure that we can call them by using the name of the class, collections. We don't need to create an object. Okay? For example, here we have an array list of a student. Okay? And we add the students 13, 3, 5, 1, 34, and 19, and 222 with some kind of value associated to that student. So we create a new students and we add it to the list. And we ask collection.sort to sort it for us. And then we go for loop for students P inside the array list, and we print them out. I want to make sure that whenever you decide to use collections or collection, you have to import java.utility and you import the specific class. The good thing that the clips, whenever you are trying to use some kind of classes that is not imported, it will ask you to import it automatically for you. But you can write this line on the top of your code. It will import all the utility classes. Here we print the student, and you can see we are relying on the student implementation, okay, to print these in order. Now we try to shuffle them. The list, print it out, shuffle again, and then we determine the maximum and the minimum of the student. You see here we define the maximum and the minimum of the students. Now this implementation of the minimum and the maximum of the students is, I didn't provide any compare to implementation. So this is actually the default implementation in case of you not providing compare to implementation. It's an arbitrary output, okay, unprotected. Maybe you take it, you run it in your machine, you will get different maximum, different minimum, okay? And whenever you sort them, it will be sorted in some kind of arbitrary orders. And you can see here, might be they are looking at the ID as a maximum, okay, detecting as an ID as a integer value. It's trying to sort the entry inside the array list based on the ID, okay? But it can be implemented totally different based on the compare to. You specify the, here's the question is, how we can find the minimum and the maximum of the object of a student. We have to look at the compare to method and see how the elements inside compare to are sorted based on the order to specify which student is minimum, which student is maximum. Now this slide will allow you to go through the element inside the list or a collection. So you can define an array list and you can ask for an object and start look inside the array list, okay? Or you can ask in a specific, I have an array list of type person, so I can for person.p inside the list, for each element inside the list, I will find it out and print it. Here is the task is just to print it. You can just take this task printing and put whatever you like to check the value, to check the status, to verify, to generate whatever you like from this object. As long as you obtain the object from the list or the entry from the list, you can do whatever you like. Another way is called iterators, which is the most commonly used by other programming language and also in the Java. Iterator is actually an interface. And the first one is more old-fashioned, you can say. The second one is the more generic type. So you define an interface of a generic type E, and you has a next as a X value. And most of the collections are actually implementing this interface. So we already told you that a class can extend only one class, but can implement many interfaces. So this interface iterator, all the collections are implement this interface. So we can ask for the next element inside the list, remove the element. This is an optional, is not always implemented by the collections. How we can use iterator? For example, here we define list1 as a new array list. We ask iterators, it1 equal list1.iterators. It will retain an iterator for us. So we can do while loop, while iterator1 dot has next, we keep looping, okay, through the element. Again, if you have an iterator or array list of type persons in specific, so we can say I need iterator of person, and list2.iterator will retain the iterator that allow you to look inside each element inside the list. Here is the behavior. The iterator is very useful tool to look inside the element inside the collections. So the state represents the position inside the collections, and the behavior is prompt to step through the collections. So allow you to go and move from one element in the collection to another element. The next slide is more like examples that I put it here for you to look inside these examples how to use the generic. For example, here is I provide a pair general or gen, and you have type of first, type of second. Here I want to from you, don't like always say I have to use T, E, V, whatever is capital. No, you can provide inside the generic whatever you like. For example, here I decided that the first element will be of type of first. Whenever I need type of first, I will throw it inside my class. You can see here the first element of type of first, the second type of seconds. Here I have first of that type, second of type of seconds. I create a constructors. I create a customized constructor, a copy constructors. So I work with the generic, okay, as I'm working with a regular type. You can replace type of first by T and type of second by U, and you proceed. You can replace it with any name you like, okay? Here I'm using it for a string and integers. I use the class that I built just to show you how we can use the generic types inside the array list. So I have defined array list of generic. So you can see here array list of generic, and then I go through this element. I print the class type for the generic. Now, this more like a performance issue. Why we have array list? Why the array list is not good, or why the hash set is good? This example, I encourage all of you to look at it at home. Try to copy the code, whatever inside the slide, and put it in your machine and see the performance. And I'm not going to go in details on this one. This is supposed to have already covered time complexity. So already we shift the time complexity later on. This is about measuring the execution time. It's not time complexity. We're not measuring the time complexity of this algorithm. We measure the execution time. How much fast to get element from the list? How much fast to get element from the hash map? How much will get from tree set? Okay? You see here, I use tree list, collections, and I use, and always in the declaration type, I use the interface type, collection. Okay? All these is, you go here, I get the value, I remove the value. So look here, if you have the hash set, you're going to have 3 milliseconds, okay, to insert, remove 1 millisecond. But if you have a linked hash set, you have 1 millisecond to insert. Why this difference because the linked list is maintaining the order with insert. I know where I insert and I'm going to insert at the end. And we'll have 2 milliseconds more slow to remove the element from the linked list, which is more natural things. To remove from the linked list, you have to remove the element and maintain the orders. While to remove from the list, you don't need to maintain the order, you just remove the element. Look at the time to insert inside the tree, 5 milliseconds. While to remove from the tree set, 6 milliseconds. But the time very long for inserting inside a array list is 82 milliseconds. And removing element from array list is 40 milliseconds. Linked list is very slow. To insert element inside the linked list, you need 145 milliseconds. So this, I hope, by go through this example, and I encourage all of you to go these examples in your computer, it will allow you to more be familiar with the collections, and also will give you an idea which type of collection should I always adopt in my application. Okay? If the speed is not important, but the order of insertion is important, may I use the linked hash set. Okay? If the performance totally is not important, I will use the linked hash set. Okay? Which one you like. Here is another example about using generics. It's more complicated things. That is actually the you see when you later on in your course, advanced courses in data structures, or maybe in the industrial when you try your job, everything has become more complicated. Everything you create a type of first, then you extend comparable interface for that. That means I need a generic type, but not any type. The type that implement a comparable interface. So I cannot assign any type that is not implement a comparable interface. So I encourage all of you to go through these examples. Okay, if you have any question, you can always see me after the class to discuss more about it. So here I define a comparable pairs. So any two types that implement a comparable interface, and actually whatever I created is actually implement a comparable interface. Okay. Here is just an example how to use it. This I print the output for you. Any question? Okay. Whenever I ask you to implement the hash code, I will give you the API specifically how to implement the hash code. In the lab test one, I ask you, for example, to find the length of the string of the shoe types plus 37 times the shoe size. So that is the only statement. Whatever you see here is just actually the default implementations for the hash code. I'm not going to ask you for do anything without providing an interface for you. Okay? Any questions? Now, the material that we covered so far, and today material up to this point is included in the lab test. 2, using the collections, compositions, aggregations, how to use the collections, and all these materials is included. Now, if someone asks about what about the previous material, about the object, to create an object, we cannot proceed if you don't know how to create an object. Okay, you don't know how to create a method and define a method, you will not be able to proceed. So all the materials will be actually part of the lab test too. But we're going to focus on aggregations and compositions and how to use the collection. I hope by today's lecture we highlighted all the collections that are mostly available on the Java and mostly used, like list, set, map, array list, hash set, linked set, and also we have a map, tree map, hash maps, how to use them, and I hope that will help you. Now, the next topics is the inheritance. The inheritance will be the major part for the lab test 3, not lab test 2. And if you have the note from the Moodle, you have chapter number 6 is talking about inheritance. When we discuss the inheritance, is what is coming to your mind is about the ability that is the new generations take from the previous generations. People, for example, in this figure, study the flowers, the white with the red, and what is that will become pink. So the ability to see the red and the ability to generate the white mixed together to give you the pink. Okay, and also such kind of ability, you see it in our real life. People to study the inheritance and generation, scientists, biologists, they start with the beans to see how that inheritance is going from generation over generations. And you see a lot of movies nowadays about X-Men, Gifted, Heroes, talking about this kind of mutations, okay? That either this mutation coming from the previous generations or this mutation is coming from nowhere. So that is in the real life, and that's kind of thing we take it and we put it inside our programming life or our programming world. Now, there's a lot of things inside our real life we cannot explain. But in this programming, we try to organize the classes that we create in some kind of hierarchy to say the base class, subclass. So we are organizing this. It might not make sense to the real life, but this is for our applications. We generate them. For example, you say, I will create a class called laptop as a main class in the root of the hierarchy. Then I will make a subclass from the laptop if I have Dell laptops, or I have HP laptops, or I have Lenovo laptop, or I have Mac laptops. These are subclasses, take some features or attributes from the main class is the laptop. This is how you organize it. But maybe someone organizes it in a totally different way. So what we're going to discuss from now on, we discuss about how we can organize our classes inside our application in such a way make it easy for us to program, easy for us to debug, easy for us to track, and reduce the amount of effort to coding, okay, by doing code reusability. So we already see the structures. We define the classes. All the classes, we define it on a separate file. To define the class, you have to create a file. Inside, the name of the file is the same as the name of the class. Okay? The class is actually a collection of sharing common attributes. A person, for example, is an object, have some common attributes. You create a class for the persons. A car is a class, implies that all car objects have the same attribute or common attributes. But person and the car are different classes, and they are listing different attributes and method and behavior. There is no like link between person and classes, but all the objects of the person, they have the same common attributes. All the objects from the cars have the same objects. But there is no connections between the person and the objects. In some applications, there's sometimes you have some kind of shared attributes between the objects or between the classes. How you can do this? For example, here we have the person object. He has the name and the phone attribute. But also, if we look at the employee and the manager and the customers, also they have the same attributes. Look here, we have the person. Any person you define, for example, if you are trying to create applications where inside your application there is a person, there is an employees, and there is a managers and customers. So the person has name and phone numbers. The manager has the name and the phone number. And the employee had the phone and the name, but also have some extra things. It's about employee ID. Okay? Now, customers have the name and the phone number. So if you're trying to create application, you're going to create a class for the person, store it in one file, a manager in one file, employee in one file. So you have different files, and all of them is within one package. But there is no link between them. There is no link between them. But you see, while you are coding, there's some kind of common. Why? All of them have the name. All of them has the phone number. How we can do this? How Java can help us to reduce the amount of coding? Not only common attributes, but sometimes common behaviors. And we saw this when we define an interface for a drivable interface. We say that bicycle and the car, they share the same behavior. They start, they move forward, they turn, they stop. So they have a common behavior. When we say behavior, we say the method. There's some kind of method that are common between the objects, not only attributes and the values of that attributes. Okay? So that, as we mentioned, employee has maintained the employee ID, which is extra information from the person. So we have actually what we call inside the Java class hierarchies. This will allow us to order the classes based on their common attributes and common behaviors. Now, this will allow us to reduce the amount of code and duplications by allow share common features between the classes. And normally, whenever we have a class hierarchy, we have what we call a family tree, where in the top of the tree is in reverse order. Trees grow from the ground as the root inside the ground and the leaf on the top. But here is in the Java, the hierarchy, the top of the hierarchy is actually the base or the superclass, the parent class on the top of the hierarchy, and the child follow. It's growing downward, not upward. So the general kind of the class will be on the top of the hierarchy, and we are maintaining a class relationship is a or is a kind of. You remember when we implement the composition and aggregation, we implement a has a relationship. Now we are implementing what we call is a implementation relation or is a kind of relationship between the classes. So we have a child, okay, more specific kind, and we have the parent or ancestors that has more generic attributes, and the feature will be on the top of the class. Here is, for example, the way we can organize the shapes. We say we have a shape, and there is 2D shapes, 3D shapes. That is actually what happened to my kid in the school. Now they just introduced the 2D shapes, then 3D shapes. So that is actually the coming with the same organization. You organize, you're trying to build an application that organized to the shapes. So you have shape in the common, you have 2D shapes. What is 2 shapes? Circles, square, triangles, and you have 3D shapes. Sphere, cube, whatever, cylinders, or, okay? So you're trying to organize things inside your applications. So this is example of a hierarchy, class hierarchy. So we say that a sphere is a 3D shape, which is actually a shape, yes? So you can see here, a sphere is a 3D shape, which is a shape, okay? So subclass is more specific, okay? And the parent or the superclass is directly above of it. So this is the superclass of the shapes. So this is the shape, is a superclass on the top. This is the subclass, cube, which is the subclass of the shape and 3D shapes. So what is the immediate parent for this class or the base class is 3D shape. That is the superclass. Direct superclass is in the above of it. But again, shape is a superclass for 3D shape. 3D shape is a superclass for a cube. Okay? All these classes actually a subclass of shape, because shape is on top of the hierarchy, is a superclass. Now, this is actually the architecture of any object you create from the Java. You like it, you don't like it, but that is the way where Java programming is built. You have the object as a superclass for any class you create. So whatever your class hierarchy you decide to create, like what in the previous slide, we have a shape. In the top of the shape, there is an object. The shape is actually object. Okay? So if you look at the previous one here, the shape is actually, there is a superclass. What is the superclass of the shape? Is object. Okay? All the classes, subclass of objects. So whatever the hierarchy you decide to create, the object will be a superclass. Okay? So we try to organize, we have the freedom to organize here in the below, but we cannot change object as the superclasses. Okay. Some fact and definitions. We say that the subclass is derived from the superclass, with exception for the object, because no one object is not deriving from that any class. Okay. So the Java only supports single inheritance. That means only single parent. So class X can derive a class that is derived another class, and so on, all back to the object. It's like a chain. You cannot have a class X extend class Y and Z. No way. You can have a class X extend Y. You can have a class Y extend Z. You have a chain of extending. But you cannot have class Y extend Z and W. You cannot have two basic class or two parents, okay, inside the class hierarchy. X is said to be descendant of all classes in the inheritance chain, go back to the objects. And all the classes X is derived from is called ancestor of X. So subclass inherit all non-private members, fields or method, but not constructors from its subclass. I want you to take half a minute, read it again and again, because sometimes students forget about this. So subclass can inherit constructors? No, we cannot inherit constructor. Subclass cannot inherit private methods or private members. Okay, only non-private members or methods we can see them. Only non-private fields we can see them. Non-private method we can access. Constructor we cannot. We cannot inherit constructors. Okay, we cannot inherit constructor of superclass. We can call them using super keyword. So, as the same, you have a new class has a direct access to what we call public and protected attributes and methods without re-declaring them or re-implementing them. So any subclass has direct access to public and protected fields or methods inside the superclass without redefining or re-implementing these methods. A subclass can define a new fields and new methods, and also can redefine what we call as an overriding, redefine the same method, but you should specify the same signature. You should write the same signature in subclass and redefine it, and that is the behavior we call overriding. Yes, that is a means we can derive a class instance in a place of ancestor class instance. This is very important. You have the shapes, 2D shapes. So 2D shapes is a child from the shape. So now this derived class, okay, and ancestor class, 2D shape is more specific from the shape. Now all the place in your application you can remove the shape and put 2D shapes, if that's possible. Most that is called a polymorphism, where you're going to see that later on. And also the ancestor can replace the derived class in some certain applications. So keep that in mind. If you build the inheritance hierarchy, then you can substitute the derived class in the inheritance in the superclass. Why? Because the derived class has all the attributes, all the methods that are not private from the superclass. So I can replace them inside the applications. We're going to come to examples. We'll become this more clear for all of you. So it's based on the implementer. This is an example about what I mentioned is about sometimes it's not making sense how we organize the classes, okay? But it's based on the implementer. You're going to look at the applications, read and collect the requirement of the application, and then organize the classes in such hierarchy that makes sense for you as an implementer. Doesn't matter if it's not making sense or not compatible with the reality. We're going to see some examples later on. Here is the example that may be matched with the reality. You have the object, you create a food class, then you have subclass, fruits, and then you have a subclass, apple and orange. So you organize things like if you build an application for a market or a store, and you organize the object in this hierarchy. This is another example for the business. You have an object in the top of the hierarchy, you have a loan, and then you have 3 types of loans: lease, mortgage, and home improvement loan. Now, how you come up with this hierarchy based on the requirement of the applications. Here is another example for the bank. You have an object in the top of the hierarchy. You create what we call a bank account, and then you have saving account, checking account. Then under the saving, you have super saving, power saving, and under checking, you have business checking, and you have our checking. Again, how we organize our classes in such kind of hierarchy is based on the application requirement. And remember that is a kind of, always this relation should be maintained while you are putting things on the inheritance hierarchy. Most of the time, the students get confused when they are trying to build the Java hierarchy between is a kind of or is a made of. Okay? That is the relation of composition and aggregations. Okay? Aggregation and the composition is a has. So, for example, a car, someone decided to have this hierarchy for the car. I would like you to look at it. Is this hierarchy, Java hierarchy, inheritance hierarchy, really implement is a or is made of? Made of. So such kind of is not inheritance. Okay? So we always should maintain, whenever you end up with the class hierarchy, always ask yourself, is a kind of or is made of? Is made of, you can create a collection inside the object to store that, okay, object. You don't need to inherit that object, extend it, okay? So how we can extend the object and build this such kind of hierarchy? We use the extend keyword. Extends keyword will allow us to extend the class. For example, in this diagram, we have A and P, and we ask A to extend P. So we can say public class extend P. So once we say like this syntax in our definition for a class A, we actually putting A on this hierarchy in this below P. So P will be the parent superclass for A. So how we can implement this hierarchy? By just simply writing extends keyword. So by doing this, now A is a subclass of P. Will inherit all non-private fields or add methods from P. Depending on the application, the class hierarchy can be organized. Okay? For example, if you have inside the university, you go to build an application for a university, and you have inside the university, you have 4 different categories: full-time, part-time, undergrad, and grad. You might come up with some, on this slide, I have 4 possible hierarchy. I would like you to take half a minute and draw a hierarchy that you might organize or you propose to that application. So you go to the university, and there is a student in the university. You ask him, he told you I'm full-time student. Then you go to another student, I'm part-time. That's a graduate student. This is undergrad student. So I'm full-time graduate students. I'm full-time undergrad students. So you have different mix of students here. Maybe some of you is full-time undergrad students. Some of you is full-time graduate students. Some of you part-time undergrad students. So how you can propose an architecture for such kind of problem? Okay, so one of the possible things, the most important based on the application requirement. It's very difficult to come up with some kind of a hierarchy arbitrary. You have to collect enough information. The provided here in the slide is not enough. Just knowing that full-time, part-time, undergrad, grad students is not enough to build an hierarchy or a unique hierarchy that anyone with receive this requirement will end up with the same hierarchy. So one of the possibility here is saying that the most important thing is knowing that part-time and full-time. I don't care about undergrad or grad. Another implementation saying I have a students as a class, then I have undergrad and grad students. I don't care about full-time and part-time. So here is as I mentioned, the focus on the full-time, part-time on the left side. The right side, we focus on undergrad and the grad students. Someone dig deep, say, okay, still the focus on the grad students and undergrad students, but still I have to recognize part-time undergrad and full-time undergrad. And again, the same thing for the part-time. Some say, no, I will change the order. The most important is knowing is full-time, part-time in terms of financial, okay? Okay, but then after that, I will ask if you are part-time, undergrad, or part-time or full-time. Okay, here is more focus on the grad and undergrad in terms of the privilege, requirement, exam styles, but you cannot focus on the full-time and part-time based on the financials and the payment and tuition fees and all of that. It's based on the applications, how you come up with the hierarchy. Okay, so these are in the Java, the subclass. These are the terms. Sometimes you look in the reference or the textbook, you see this term, subclass. Subclass is the same as child, inherit attributes, okay, and the behaviors, methods from all superclass, ancestors or parents in the top of the hierarchy. So that is you can say on the object-oriented programming, inheritance is an act. Okay, so inheritance is an act. Inside the Java, we perform this act by using keyword extends. That's right. So its inheritance is an act of receiving a shared attributes and the behavior from more general type of objects up on the hierarchy. Okay, so all the general attributes from the superclass will be inherited on the subclass, and there is an ability for the subclass to define a new attributes and also a new method to be added to the general class. Now, what's the advantage of using inheritance? It's sharing. Okay, allow the code to be shared between the classes and save time for programming. We don't need to duplicate the code, reduce the effort to develop the code and write the code. And simple, make our life simple and easy, okay, if you build the applications. This is an example for an kind of questions that you might see. It's you go to the company, and company maintains the name and address, phone numbers, employee ID, and hourly pay rate for all its employee. And also there is a few companies, that's a few of the company employees are managers. And once you have a managers, then you have a list of duties, and for each manager they have a list of employee to work with. So by looking to this, you say, I have a company, I have an employee, and I have managers, and there is a difference between the employee and the managers. How I can come up with the hierarchy that's suitable for this problem? Okay? Let's see. Someone say, okay, employee and managers. So the employee I have, there is a name, address, and he consider address as an object. And then we have a phone number, and we have an integers as an employee numbers, and we have flat hourly rate. That is the employee. That is the superclass. And then we extend the employee because all the managers actually employee. But there is a difference here that the manager have a list of duties, and the manager have a list of employees to work with. So we say manager extend the employee, we have list of duties, and we have list of employee to coordinate with. Someone say, no, I will have a person, then I have employee, and then I have a managers. So I have person, I have name, address, and phone. Person, employee extend the person, where I have employee number and hourly pay, and also I have manager extend the employee. And look here, the employee inherit 3 attributes from the person. All these attributes are public, so employee inherit these 3 attributes from the person. So now the employee has actually 5 attributes. Even in our code, we only define 2. We rely on the person for the rest. Now, the managers extend the employee. That means the manager has 3 attributes from the person and 2 from the employee, and has also 2 extra attributes is defined inside the manager. In total, that's 7 attributes. This is another example where you have the bank, and the bank has all the bank account, always have the owner name, account number, and the balance. And all the bank account have the default that they can deposit and withdraw. So you can say, I have object and have a bank account. You can see here, we define a class. We have 3 attributes, or 3 fields: owner, account name, balance. We have the constructor, default constructors here. Okay, and we have the customized constructor. We provide the name. We initialize the account number by 0 and the balance by 0. We deposit and we withdraw. Okay, we continue next time discussing more about the inheritance.